All right, in our new unit in algebra, there's a whole language that's really associated with algebra. And before we can start doing the math, we have to know the vocabulary that's associated with it, just like any other language. So that's what this lesson's going to be about. We're going to understand the vocabulary that we're going to be using when working with algebraic expressions. So if you notice, I highlighted the word algebraic expressions because that's the first word that kind of we need to know what it means. So you don't have to know you don't have to have the formal definition memorized. I've included it on here. It's a mathematical expression that consists of variables, numbers, and operations. The value of this expression can change. So I put an example of an algebraic expression on here, and there's some parts to this that we need to know the names for. So the first thing is, and it pops up in the definition there for algebraic expressions, and that's of operators. So in this problem, the only operators we're using are addition. The only ones that you can see there. But there's also minusing, there's dividing, and multiplying. There is multiplying that's going on in this problem. In algebra, when you see a number right next to a letter, 2y, what that means is 2 times y. But for this one, the ones that are most obvious are the addition signs. So that's the first thing, is knowing what an operator is. Then it's what a term is. So you've got those operators like addition or subtraction, and what they do is they kind of define what the terms are in the algebraic expression. So this one, we have those 3 plus signs, which basically divide this algebraic expression up into 4 terms. So that's the second word, terms. And then the next part, and this is a big one with algebra, is that of variables. And you've probably, at least heard the word or maybe done a little bit of work with variables. But in algebra, usually we let just letters represent the variables. They don't have to be letters, but that is the most common. So like in this problem, the variables that are being used are x and y. Now, you do see an exponent there, and then in that third term, the x and y are actually together, but the actual variables that we're using are just x and y. And then you've got coefficients. So coefficients are the numbers that are, if I'm looking at it visually, it's the numbers that are right in front of the variables. But if I was talking about it more mathematically, it's the numbers that are being multiplied by the variables. Because remember, this means 5 times x squared, and this is 2 times y, and this is 9 times x times y. But the coefficients are just the actual numbers. You notice that when I put a box around them, I also put a box around the operator that goes in front of it. I did that on purpose. It's because that operator is kind of attached to the number that follows it. And that becomes important, especially when we start working with throwing some minuses in here. Because if that was a minus 2y in here, so if I wrote minus 2y, the coefficient would actually be a negative 2. And if you notice, the one that I didn't put a box around was that last, the plus 4. That's because it's got its own special name too. That's called our constant. It's called a constant because it's always going to be equal to 4. Those other terms can change, the value of them, depending on what the variable x and y actually represent. I haven't told you what x and y represent. We'll be doing that soon enough. But for right now, you just have to know that that last term is called a constant. I shouldn't say the last term because it's not always the last one in the expression. It could be anywhere in the expression, but it's the one without the variable. All right, then the last kind of vocab that you need to know is what a like term is. So like terms are terms that have the same variable. Okay, for example, in this question, 5a is a like term to plus 8a. And again, I'm highlighting the operator with it because that's included. And then you've also got plus 6b and plus 9b. Okay, those are going to be our like terms because they've got the same variable. And not only the same variable, but when we throw exponents in there, it has to have the same variable and the same exponent. So if I look at 5x squared, I wouldn't say that 5x squared and 6x are like terms because they also have to have the same exponent on the variable. So 5x squared is a like term with plus 8x squared, and then you've got plus 6x and minus 4x. And then last but not least, you've got plus 7 and minus 3. So those constants can also be looked at as like terms. All right, so you're going to answer a couple of questions related to this vocabulary. Question 1. Are there any like terms in this expression? Question 2. How many terms are there? Question 3. What is the constant? Question 4. What is the largest coefficient? And on this one, I might have tricked you a little bit because probably what a lot of people said initially was, oh, the largest coefficient is going to be 10. Actually, probably what some people do is they just look at that and they say, oh, look, 10, that's the biggest number, so that's going to be the largest coefficient. But you got to remember that minus sign is attached to it. So that's actually the smallest coefficient because it's a negative 10. So the largest coefficient in this one is a positive 6 value. All right, so let's go through and do the same questions, but with a different expression. So for a new expression, are there any like terms? How many terms are there in this expression? And last but not least, what is the constant? And remember, for this problem, the constant isn't just 12, it's minus 12.